Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain numerical application chemical kinetics part 3. This is introduction part 3 where I am going to explain some concept, some graphs and formula related to with gas phase. We know before fast reaction and their concept formula, and here I will explain faster reaction with gas phase. Before that, we should see again the faster reaction graphs which are explained in part 1. Then only it will be easy with gas phase. There are two types of graphs you see. In two types of graphs related to first order reaction which is explained in part 1. Sorry, it is not part 1, it is part 2. It is part 2 and here it is also part 2, not part. So, there are two types of graphs related to first order reaction. One is ln R, molar concentration R versus time, and another is log. See what is difference between log and ln? What is difference? Tell me, what is difference between ln R and log R? ln mean where here 2.303 not separately you have written, but log R you will write 2.303. That means ln equal to log 2.303. So here you will see this is first point important graph, that is you will see ln R versus time and log R versus time. R mean here you will see molar concentration of, and second one you will see ln R0. ln R0 mean concentration of R, initial concentration. When you write initial concentration, it is R0. When simply you write R, then it is the instant time concentration. At particular time you will see the concentration, that is molar concentration R, having put your sign, that is square bracket. Now ln R0 by R versus time. Other one also you will see log R0 versus R0 by R versus time. So what is log ln? I told same thing. ln equal to log into 2.303. So when graph is plotted between, first you will see log R versus time, then its slope is minus k 2.303, because the equation is here, you see the equation is log R equal to minus kt by 2.303 plus log R, where log R0, again see log R equal to minus kt by 2.303 plus log R0. So what is the slope here? Slope equal to minus k divided by 2.303. And what is intercept here? Log R0. See here, this is the intercept you can find here. This is log R0. So I hope clear. And the equation, what is the equation here? Y equal to mx plus c in the form. Y mean log R, t mean x-axis, and log R0 mean C, intercept. So here log R in y-axis and t in x-axis, and slope is minus k 2.303. If graph is plotted between ln, you are taking ln, not log. ln mean here 2.303, you can see only ln you will write. So mathematically you should remember ln equal to log into 2.303. So 2.303. Okay. Then here in y-axis what you will put? ln R. This is your y-axis. And this is your x-axis, that is time. This is x-axis. Then intercept here ln R0. In that case intercept 1, log 1. So here slope equal to how much? Slope equal to minus k, because what is the formula? ln R equal to minus kt plus ln 0. Then you will see, if you will see here, this should be b. This should be because a is over and this is b. And again you will see 2a. 2a means you will see log. Here what is if the graph is plotted between log r0 by r. R0 means initial concentration. How can you write? R square bracket 0. And R means here particular concentration of the reactant, particular time, and here so at particular time you will see the concentration. So you write here R molar concentration. If the graph is plotted between a log R0 by R and time, what you are getting? A straight line, but it is crosses the origin. Here 0. Here you will see that straight line is formed crossing the origin. So what is the value here? Slope equal to k 2.303. And very important, you can observe there is no negative sign. Why? Because here the formula is log R0 by R equal to k 2.303 t. So if you plot the graph between log R0 molar concentration divided by R molar concentration versus time, then you will get a straight line and slope equal to k divided by 2.303. So these are the graphs which I have explained in first order, that is introduction part 2. Now we'll proceed to the phase, gas phase. But before that you will see ln. ln here, ln means ln R0 divided by R versus time. So here also slope equal to k, and here also that y equal to in y, what is that one? Ln R0 by R. That means here you can see in y-axis what you will put? You will put ln R0 by R. And in x-axis what you will put? T. Value of time you will put here. Value of ln R0 by R you will put here. Then you will get a straight line and it crosses origin. So slope equal to k. So these are the important graphs which are very, very important in gas phase, in titration phase, and also in polar meter rotation. So the concentration of solution expressed till now, what you have learned? The concentration of solution is expressed by moles per liter. But when you come to gas phase, it should be expressed by atmosphere. Because gas means having pressure, so we will express atmosphere. So let us see with gas phase. A gives B plus C. All are gas. So what to do? You will see what is the initial pressure of A before the reaction. Let Pi is the initial pressure of A. All are in atmosphere, remember. PT means total pressure. Total pressure time T, that means A plus B plus C. That means PT equal to PA plus PB plus C. That is called P, total pressure at a time. Let us see what are the pressure of B and C at a particular time T. So first you will see what are the pressure at a T equal to 0. When T equal to 0, the reaction is not started. That means here Pi atmosphere, it is remain as it is because the reaction is not started. So next is B. When the reaction not started, T equal to 0, and B that pressure 0 atmosphere. C also pressure 0 atmosphere because reaction is not started and time is 0. But when time equal to T, at a time T particular time, then what is that? P minus X. Let X is the used atmosphere and Pi minus X, then X atmosphere, and this is C also X atmosphere. Remember, at a time T, Pix, the atmosphere of A, X atmosphere of B, and C also having X atmosphere. Then how can you calculate the total pressure, PT? So you will write Pa plus Pb plus Pc. Now you add it properly. After adding, what you will get here? That Pi plus. You will get Pi plus. Now what is x? How can you calculate x? See, Pt equal to Pi plus x. So x equal to Pt minus Pi. And Pa equal to, you can find Pa equal to, it is there already, Pi minus x. So you got all the values. Pa equal to, what is that one? Pa plus Pb plus Pc. So the total result is 2Pi minus Pt. 2Pi, that means that Pa equal to 2Pi minus Pt. After calculation, you will get this value. What is that? Pa. And what is, so K equal to 2.303 by T log Pi Pa. What is Pi? Initial pressure. Initial pressure, that means as you know, in concentration of solution K, you should write R0 by R. So Pi is the initial pressure and P is the pressure at a particular time. So what is the value? That is K equal to 2.303 by T log Pi divided 2Pi minus Pt. I hope it is clear. What is your aim? Initial pressure, that is already given, that is Pi, and final pressure, that is for A, that is P2Pi minus Pt. This is the first order equation for the gas phase. After that, it is related, what is pseudo first order reaction? You know the first order reaction very well, when it depends on the power, that is power 1 to the concentration of the reactant, raise 1 power. And here experimental determination order is different from expected order. That means what you see, what you think that it should be, but not. Actually, determined value is different. So one of the reactant in water in large excess, it looks like second order, but it is first order, because the one of the reactant is water, which is present in large. If present is large, that is, it is a constant value, it is not calculated. So here examples of pseudo first order reaction, very very important in our 12th class chemistry. And inversion of cane sugar, hydrolysis of ester. For 2, we will see different type of formula we will use. So when you come to inversion of cane sugar and hydrolysis of ester, inversion of cane sugar we will study later in coming video, but you will see first hydrolysis of ester. In hydrolysis of ester, it is a solution, and here volume word is used. Here volume word is used because here, according to titration with KMnO4, we will calculate the volume of the ester, how much used. One example, simple example, here decomposition of hydrogen peroxide. In decomposition of hydrogen peroxide, here it is not, that means it is not a pseudo first order, but simply how it is, volume is calculated by making titration against acidified KMnO4. Now solution is titrated against acidified KMnO4 with dilute sulfuric acid. That means acidified KMnO4 you will use. Then volume of KMnO4 before commencement of reaction. Before commencement of reaction, what is the volume? And that is initial. Then what is related? That means you are not using the volume of KMnO4 titration using, but you will make, it is proportional to initial concentration of hydrogen peroxide. When initial concentration of hydrogen peroxide, let A, small a, of the reaction, then the volume at 0 time is V0. So, what indicates before starting reaction volume of KMnO4, how it will calculate, that is proportional to initial concentration of A, that is volume at 0 time, that is V0. Volume of KMnO4 at instant time, then what happened? That is Vt. At instant time, particular time, Vt. Vt proportional to that is volume hydrogen peroxide present at that time. At that particular time, what is the volume of hydrogen peroxide? That is A minus X. And since it is first order reaction, then what happened? Yes. Hydrolysis of ester. Okay. Then it is first order reaction. So what to do be formula? Formula is K equal to 2.303 by T log A by A minus X. But I told just now, A, small a, proportional to V0, volume of KMnO4 using in titration. So, K, that means K equal to 2.303 by T log V0 by Vt. So, volume of KMnO4, that is equivalent to volume of hydrogen peroxide. So here this is the simple one, and it is generally the question when asked hydrolysis, not hydrolysis, hydrogen peroxide, it gives what? The decomposition of hydroxide, which gives water and oxygen, and the numerical problem will be given. You will write the formula where V0 value should be given, Vt value should be given, and you can calculate K or T according to the question. Now the important is pseudo first order reaction. You will see first order reaction, that is with hydrolysis of ester. Now see, in the hydrolysis of ester, water also used. Water is used in large excess. So the value is taken as constant, and so it is called pseudo first order reaction. Example, ethyl acetate plus hydrogen in presence of acid, it gives acetic acid and ethyl alcohol. Again see, ethyl acetate on hydrolysis with water and acid, it gives CH3COOH, acetic acid, and C2H5OH, that is ethyl alcohol. Then we will see how it acts as a pseudo first order reaction and what is the first order reaction formula. Titration is done against standard NaOH. Here KMnO4 not used. Standard NaOH means whose strength is known. Volume of Na solution in the beginning T0. When beginning, time is T0, and that is volume of acid present as catalyst. That means ethyl acetate plus acid, which is helpful for that is hydrolysis in presence of water, and that act as a catalyst. So volume of acid present, that is proportional to volume of NaOH solution, then it is V0. Similarly, volume of solution at instant time, particular time, that is Vt. Are you clear? Again see, when time is 0 and the volume of acid which is used as a catalyst proportional to V0. V0 means volume of NaOH at time T0. And similarly, Vt mean here it is proportional to acid as catalyst, amount of acetic acid. So that is equivalent to volume of NaOH at particular time. So Vt is the equivalent to acid as catalyst, that is plus amount of acetic acid. Amount of acetic acid is the what? Acetic acid is the product side. So amount of acetic acid produced at instant time proportional to what? Vt, particular time, and minus V0. V0 means at particular time not, it is T0. T0, what is the volume of NaOH? Vt at a time t, what is the volume of NaOH? So Vt also equivalent to acid as catalyst plus amount of acetic acid. But the amount of acetic acid produced at instant time is the amount of ester related. What is the ester present, and that is equivalent to your amount of acetic acid. So the amount of acetic acid proportional to Vt minus B0. See, it is little complicated. Only lastly you observe what is the formula. That is very important, because something is produced that is equivalent to, proportional to NaOH, that looks like a complicated, but if you read 2 times then it will be easy. You can see B0, that is at time T0, NaOH, that is volume of NaOH, and that is volume of acid also, that is proportional to B0. So the Vt mean at time t, and X is the amount of acetic acid. Okay, then you will see the formula. If the reaction proceeded for long time, but if the reaction proceeded for 1 hour, half an hour, then it is okay. But if it proceeded for a long time, that is 24 hours or more than 24 hours, and that is regarded as known as infinite time. What you will know this one as infinite time. The reaction proceeded for 24 hours or more than 24 hours, then what is the final value? That should be V infinity. So V infinity, the amount of acid present as catalyst plus amount of acetic acid. So you will see what is the amount of acetic acid, you can say, and what is the amount of acid present as catalyst, that is equal to V infinity. So V infinity, that is volume of NaOH used for long time. So what is the formula then? The formula of ester reactor, initially A, and what is the amount of ester reactant, that A minus X, and here A minus X, the value comes to V infinity minus Vt. Vt mean at particular time t, V infinity mean for a long time it is proceeding. So what is the equation? That mean here 2.303 by t, there is no problem, log A by A minus X. But if it is continuing for long, because this generally hydrolysis of ester proceeds for a long time, maybe 24 hours, 2 days, 3 days also. That is why you will take as infinity the V infinity by V0, and that is value A. A is proportional to V0 minus, V infinity minus V0. A minus X equal to V0 minus Vt. V0 mean that is you are at initial concentration. So V0 minus Vt, that is A minus X. See, simply read formally and read, try to understand. It is very easy, but something is complicated, but equation is very easy, and equation is very important for the numerical problem. So you should remember the value of that one. You should calculate the value from the given value in question. So V infinity should be given, V0, Vt should be given, and wherever you can calculate k value, or you can calculate t value, and where V infinity, V0, Vt value given, and put the value and calculate. If different time is given, you put different time for 3-4 equation, and the value comes to constant, then you can say this is first order. How can you prove first order? By making correct constant value same. So here this is the hydrolysis of ester, and it is a pseudo first order reaction. And here rate of reaction for hydrolysis, again I have written the formula, the value here k equal, always write k equal to rate of reaction for the hydrolysis, okay, but here what is the value, what is the reaction cost, actually that formula k equal to 2.303 log this one. So hydrolysis ester is a pseudo first order reaction. You should write pseudo first order. I hope it is clear. A little bit hydrolysis of ester is complicated, but the formula is very easy, and you should remember the formula. The value should be given in the question, and so I hope it is clear to you. Try to read 2 or 3 times, then it will be easy. Thanks for watching my video. Myself B.L. Das, ex-PGT Chemistry, Kendriya Vidyalaya Sangathan. Again, thanks for watching my video. Thank you again.